In problems 2 and 3 on the review, you're being asked to determine if the sequence is arithmetic, geometric, or neither. If a sequence is geometric, it will have a common ratio, r. If a sequence is arithmetic, it'll have a common difference of d. Basically, to find a common ratio, you would take a term and then you would divide by the previous term. And to find a common difference, you would take a term and you would subtract the previous term. So I would start out by taking negative 64 and I would divide that by 16. That gives me negative 4. Now if I do the same thing for 16 divided by negative 4, I also get negative 4, and then of course negative 4 divided by 1 is negative 4. So every time I do a division problem where I take a term and divide it by the preceding term, I get the same answer. So therefore it is a geometric sequence whose common ratio is 4. Let's take a look at number 3. If I take 7 and divide by 3, I get 2.3. If I take 12 and divide by 7, I get 1.7. That's not the same result, 2.3 and 1.7. So I know it's not geometric. So let's try subtracting. If I do 7 minus 3, I get 4. 12 minus 7, that's going to be 5. 18 minus 12, I get 6. So I'm not getting the same answer there either when I do subtraction. So there's no common difference. So because there's no common difference, nor is there a common ratio, I would have to say that problem number 3 fits neither of those criteria. So it is, the correct answer for 3 is neither. Okay, let's take a look at question 5. All right, for question 5, what you're being asked to do is write the first 5 terms in the sequence. So you're given A1 is 5, and then you have 3 times the previous term minus 4 is going to give you your next term. There's a little bit missing from this formula right here. We should say a term in the sequence, that's a sub n, is given by 3 times the previous term minus 4. Recall that this means previous term. Okay, so if I want to know A2, I need to use A1 because that's my previous term. So I would take 3 times A1 and I would subtract 4. So 15 minus 4 is 11. If I want to take A3, if I want to find A3, I would take 3 times my previous term, which is 11, and subtract 4. So 33 minus 11 is 29. And then A4 will be 3 times my previous term minus 4. So I type that into my calculator, 3 times 29 minus 4, and I work that out to be 83. Then I need to find A5, and that's 3 times my previous term minus 4. So I need to do 3 times 83 minus 4. And that is 245. Your calculator can be used to figure out the 5 terms in a sequence for a recursive formula. Here's how you can do this. Take 5, which is your first term, and press enter. Then type in the second expression, 3 times my previous answer, so do second answer, minus 4. So that's going to give me 11. And then I'm going to take and just hit enter because that will call up the same expression. 3 times my previous answer minus 4, I get 29. 3 times my previous answer minus 4 gives me 83. And then I end up with 245. So that's another way that you can do recursive formulas on the calculator. Okay, in order to do question 6, you are basically figuring out the first 5 terms in the sequence. There is a minor typo here. I just want to fix this for you. This should say 12n plus 20. So if I want to find A1, I would do 12 times 1 plus 20. If I need A2, I do 12 times 2 plus 20. A3, 12 times 3 plus 20, and so forth. Okay, so I set up all my calculations for A1 through A5, so I'm going to plug in 12 times 1 plus 20. Okay, so I entered my first four problems. I did 12 times 1 plus 20 and got 32. 12 times 2 plus 20 is 44. And then I had 56, 68. So my last one I'm doing is 12 times 5 plus 20, which works out to be 80. And so there's your first 5 terms of your arithmetic sequence.